So in this video, we'll perform a mole balance on a CSTR, or continuous stirred tank reactor. And a CSTR is a flow reactor, such that we have a molar flow rate, we'll call it FA naught, coming in. And we'll do our balance here with respect to A, and usually we'll have A as a reactant. It could be as simple as just A goes to B, which is what we'll just assume here. But of course it could be A goes to B plus C, or A plus B goes to C plus D, or any other numerous combinations. And our CSTR is well mixed, such that our exit molar flow rate, FA, is presumed to be the same as the conditions inside the tank. As with any balance, we're going to look at our rate in, which in this case is FA naught, and our rate out is FA. That's our molar flow rate at our exit. Our rate of generation is the rate of formation of A multiplied by the volume of the CSTR. And our reactor is of constant volume, and because it's well mixed, our rate of formation of A is independent of that volume, such that we just have RA multiplied by the volume of the reactor. And this is going to equal our rate of accumulation. And the CSTRs are steady state reactors, such that our rate of accumulation is 0. So our mole balance with respect to A for a CSTR is just the initial molar flow rate of A into the reactor minus the final flow rate of A out of the reactor, FA, plus the generation of A, which is the rate of formation of A multiplied by the volume of the reactor, and that all equals 0 since there's no accumulation. Now we can rearrange this equation and solve generally for the volume of the CSTR, such that we get V is equal to the initial molar flow rate minus the final molar flow rate out of the reactor all over minus RA. You'll note that we put minus RA in the denominator, as it's customary because A is often the reactant, such that the rate of formation of A is negative. And for a continuous stirred tank reactor operating at steady state conditions, this is all there is to the mole balance.